All right, so we've been working with 3D, lines and planes, and now we're starting to talk about areas and volumes. And one thing that we established is that the area of our parallelogram, where you have points A, B, C, D. So I just typed in some random points here. We've got, I'll just label them for you, points A, B, and C. And those are our three basic points. And if you use the direction vectors, then you can figure out point D has to be at 408, just to make sure that it's parallel to the other sides. And we found that the area of ABCD is going to be the magnitude of our cross product of AB cross AC. Or you could do BC, and you'll get the same answer. Okay, but what we're going to talk about now is what if we go and we add another point off of it, so you make a parallelopiped. It's like the 3D version of a parallelogram, and so it's kind of like a rectangular prism, but the angles might not be 90 degrees, and so that's why we use parallelopiped as the word, because all of the different faces are parallel, all the different edges are parallel to the other pairs there, but they're not 90-degree angles. Okay. And so what we're going to try to do is figure out a formula for the volume of it. Okay, so here's the idea. I know that if I have a 3D shape, like a cylinder or something like that, then I just figure out the area of the base and I multiply it by the height. And I also know, if you think about it kind of like in calculus terms here, if you have a 3D shape that's tilted, you can still find the area of one of those layers, and you just are like adding up how many of them there are in the height direction. Okay? Cavalari's principle is the idea that even if you tilt it, as long as all of the stacks are the same size, you can just add up how many there are as long as you go perpendicular to the base. So the H needs to be perpendicular to the base. So now what we know is that the volume of our parallelepiped is going to be the area of the base multiplied by the height of the shape. And again, the caveat is that the height needs to be perpendicular to the base. So if I have my parallelogram right here, I need to draw a right angle and then create a side length like this that is equal in height to where this point E is, right there. So I somehow need to use the coordinates of E to figure out the height of the parallelepiped. Let's call this angle that AE forms with the base of the parallelepiped. Let's call that angle theta. What that means is that this angle on the inside of the triangle right here is 90 minus theta, and that this angle up here is just theta once again. Okay? So what we're going to do is we're going to use our a couple ideas to come up with an expression for H that gives us a nice formula that we can use for the volume of the parallelepiped. Okay, so here is what I'm thinking. When we do the cross product, think about what the cross product gives you. The cross product gives you a vector that is perpendicular to the vector that we want. So I know that the cross product is going to be a vector that is in this same zone as H. It's going in the same direction as H. It may not be exactly as long as H, but it's moving in that same direction because it's going to be perpendicular to the base of the parallelepiped. Okay, so what I know is that if I look at the cross product AB cross AC, this forms a certain angle with AE. Remember, AE is this part right here. Okay, and so the angle between those is 90 minus theta. Okay, so I know that if I did cosine of the angle in between those, 90 minus theta, that would equal the cross product dotted with AE divided by magnitude of the cross product times magnitude of AE. So that's just your basic cosine of theta formula for two vectors. The only slightly weird thing is I labeled that as 90 minus theta because it's not the angle between AE and your base of your parallelogram. It's the angle between AE and the normal to your parallelogram. So that's why I did 90 minus theta. Okay. Now, this right here is equal to cosine of 90 minus theta. But if you think about a right triangle, if you have cosine of 90 minus theta, that's going to be the same as doing sine of theta. The adjacent side of cosine is the opposite of sine when you switch from one corner to the other. So that's going to be sine of theta. So keep that idea in mind. We're going to grab this. Now we're going to think about it just like a right triangle. If I'm sitting here in this right triangle, theta and h are opposite of each other. So I know that sine of theta is opposite over hypotenuse. And the hypotenuse here is this vector AE. Because I'm thinking of it as the length of the hypotenuse, I'm going to say it's the magnitude of AE. And so I actually have now two different expressions for sine of theta, which means those two things need to be equal to each other. And the benefit of setting those equal to each other is, remember, don't lose sight of what we're trying to do. We're trying to find the volume. And the thing that we need to know to find the volume is what is h. So if I set this sign here equal to this sign here, then I can solve for h. And I get that h, I need to just multiply AE's magnitude over here. So h is AB cross AC dotted with AE over magnitude AB cross AC and magnitude AE, and I needed to make sure that I multiplied by magnitude AE. Okay, so you might be thinking this is getting worse and worse and worse, but stuff starts to cancel out. Notice that magnitude of AE is on the top and the bottom. Now I'm going to grab this h and copy and paste it over here. And do you see what else cancels out? This ABAC and this ABAC. So the magnitudes cancel out. So all that's left over then is just this part on the top. Okay, and then the only last detail is we know our volume has to be positive, and so we just want to make sure that we put an absolute value around it. So after all that work, we come up with this really nice formula. I'm going to clear everything out. I'm just going to rewrite it. The volume of our parallelogram is just the absolute value of AB. Oh, come on, pen, don't fail me now. AB cross AC dotted with AE. My pen is failing me. Okay, so first you do the cross product. That gives you the area of the base. Then you do the dot product to get you up to the height. Then you do the absolute value and you get a positive number. That's it. All right, thanks for watching. Let me know if you have any questions.